Thanks again to everybody on the call for taking time out of your busy day to join us in this webinar. So as Mark mentioned, my name is Chad Mack. I'm the product manager here at GTT, and I'm responsible for product roadmap, product portfolio, and ultimately working with folks like you to understand your needs, and then taking that back to our engineering development folks to develop and launch solutions to meet those needs. And our focus today is really going to be around preemption and priority control in the smart city. Obviously, as you guys know, smart city is getting a lot of attention, the Smart City Challenge, also kind of new, innovative startup companies moving into this space. A lot of great ideas and technologies coming to the smart city. And so we wanted to give you some context for where preemption and priority control fit in all of this and how GTT sees ourselves playing in this space, and ultimately how we can help you. Where does GTT fit in the smart city? And then from there, we're going to take some time to talk through a few of our solutions, specifically as it pertains to connected vehicle and preemption and priority control solutions. And then we'll get into a couple of examples, one being a case study from New York City, and a project that we've been working with them on for the past 6 to 7 years. And then lastly, we'll kind of bring it all together with a recap. All right, so let's jump into things. So before we get into the GTT specific content, I want to kind of set the stage with some context around smart cities. So depending on who you ask, you'll get a different answer for what a smart city means. But at the end, what a smart city really is it's a city that connects systems and infrastructure to operate more efficiently, with the purpose being to be able to better serve the citizens as city and population densities increase in those cities. You need to be able to leverage the same infrastructure to serve those citizens. So definite challenge. But if you think about the smart city space and how GTT fits, we fit right in the center with transportation. So as you look across the city, there are multiple modes of transportation set for moving people, moving goods, but in the end, what GTT offers and where we see our role in the smart city is really in changing the way the city moves with intelligent transportation solutions. So not only on the vehicles, but also on the infrastructure side with those traffic signals and traffic management centers, the folks that are dictating how goods and people move throughout the city. We need to be able to bridge both sides. But if you start to think about the smart city, there are several challenges to deploy a transportation solution. And it really starts with the transportation infrastructure. So if you look across a city, there are multiple components that are impacted by transportation and the movement of people and goods, starting with the vehicles themselves. The onboard vehicle systems that can vary from city to city, but it's those computers, potentially your connected vehicle equipment, GPS, connectivity. On the intersection side, what exists there? Your signal controllers, your traffic management center, potentially your software solutions, your ATMS, and again, your connected vehicle equipment. On the communication side, what level of connectivity do you have across your city? Is it some sort of legacy copper connectivity, or do you have fiber to your intersections, and to what level have you deployed that activity? And then lastly, in your control center, your back office, so analytics tools, data management systems, what is available there and how accessible is it for folks like GTT or outside manufacturers to be able to interface to that? So there are really a number of constraints that impact this transportation infrastructure and deployment. So technology can really vary across departments and cities or even regions. So you may have a partially connected fleet, partially connected intersections. Maybe you have onboard computers on a limited number of vehicles, but not all the vehicles. Or maybe transit doesn't have any onboard computer, but your fire department does. These are all real scenarios that cities face. Another constraint is on the budget side and asset ownership. As you think about connected vehicles, it's connecting not only vehicles to infrastructure, but it's connecting the transit department to the traffic department. And so those assets are typically owned by different groups, and the budgets for those groups are different. And so those are dynamics that have to be navigated when you're thinking about a smart city, kind of connected vehicle solution. And then lastly, as you start to think about what equipment exists across a city, the equipment could be provided by a number of vendors. So it's common for us to work with cities who have multiple controller types. Not only are they legacy controllers and ATC controllers, but they have controllers from manufacturer A and controllers from manufacturer B, and in some cases, manufacturer C. And in the same context, the CAD AVL vendors can vary, especially as you start to cross from transit to emergency services and then delivery services. Those CAD AVL providers typically aren't the same. And so with all of these technologies, and that's really where GTT specializes in. So if we transition now to GTT at the highest level, we really see ourselves as providing three core values. The first is our trusted expertise. So we have over 3,100 customers worldwide, including 41 of the 50 largest US cities. And so through this, we have tremendous experience in bridging departments, bridging regions, and also working with manufacturers in a variety of different markets to make an integrated solution work. The second piece is tireless innovation. So a lot of our customers know us for what we've done great for the past 30 to 40 to 50 years, and that's emergency vehicle preemption and transit signal priority. Those specific applications have evolved significantly over the years to include the latest technologies, going from infrared kind of point to GPS-based radio, and now to things like cell and eventually 5G and DSRC. But then also leveraging the standards. As standards evolve, we incorporate standards into our products. We also guide the standards with voting membership on a number of the leading standards today. And then the last piece, this is an area of emphasis that GTT has really started to focus on over the last 3 to 4 years, and that's total assurance. Gone are the days where you could deploy a solution with a customer and then walk away and trust that it works. For us, knowing that technology is coming at our customers at a rapid pace and it's difficult to manage and train and maintain, our focus is really in forming a partnership with our customers, not only to identify and deploy the correct solution, but then also make sure that they're getting the most out of that solution over time with our customers, not only to identify and deploy the correct solution, but then also make sure that they're getting the most out of that solution over time. And I'll talk to you a little bit about what we're doing there. Okay, so we apply these values in really 3 key areas. The first is in the smart cities, and the focus there is really in helping cities to manage the movement of people and goods in a safer and more efficient manner. And then the other 2 markets that you may be more familiar with for GTT, intelligent transit, so supporting transit agencies to increase ridership, enable better on-time performance, and achieve reliable schedule adherence, and intelligent safety, helping to get first responders to the scene of an emergency safely and quickly. Okay, so what this breaks down then is into a number of use cases. So as you think about the smart cities perspective, moving people and goods, really focus in a handful of key areas. Multimodal transportation planning. So working with cities to identify a technology plan for their fire department, for their transit services, for their EMS, and even thinking of more kind of futuristic smart city, private entities like delivery services, and putting together a plan to make all of those modes work in a cohesive system. Second key area that we help a lot of customers with is with connected vehicle and technology migration planning. So maybe they have a legacy connected vehicle solution today. Maybe it's our Opticom IR technology, and they're looking to move to a smarter solution that's more integrated. We will help them to make that transition, understanding that their infrastructure could vary across the city. Dynamic and adaptive signaling. Obviously, there's a heavy push on the traffic side to get to that place, especially as you think about connected vehicles and autonomous vehicles. but there are some important decisions to make on the connected vehicle technology side to ensure that those solutions effectively support adaptive and dynamic signal timing. So we're working with cities on that as well. And then kind of the newer, think about the last 2 to 3 years, newer kind of focus, Internet of Things and data management. So the idea of connecting more things to a central location, and then once you connect them, how do you manage the data, centralize the data, and access the data in a way that's effective for all the various stakeholders. And then the last one, not to be understated, stakeholder collaboration. If you've been to any of the kind of industry trade shows that talk about smart cities, one of the most commonly talked about topics is public and private partnership, and that spans public departments, academia, and private. And so our focus is really on bridging that. And obviously we have a breadth of experience with our 40 plus years in the industry with all of those stakeholders. Okay, so the second area then, intelligent transit. As I mentioned, a lot of you know us in this space. So it's really focused on multimodal transit, whether it's fixed route buses, BRTs, light rails. Again, putting together a technology plan that supports all of them, understanding that the infrastructure can vary on those vehicles. But then also focusing on route performance and planning. Transit signal priority is one tool of multiple tools that can be deployed from a technology perspective. I'm not going to spend a lot of time on our connected vehicle platform today, but that connected vehicle platform blended with transit signal priority can ultimately improve route performance and planning, as an example. And then lastly, analytics and reporting is core to any technology system that's being deployed today. EMS, if you think about a fire department's response relative to what a police department may respond to in a given day, PD may not always need preemption when they have their lights on versus a fire department will. So you have to do preemption smarter in order to blend those modes in. And again, connected vehicle technology, spanning the different vehicle types, knowing technology can vary, and then ultimately analytics and reporting to ensure that they're getting the most out of their system. These are all things that we work with customers today, and the challenge, but also the process that we've put in place to address this, is understanding what the city has for goals and also what they have for infrastructure. And through that, we're able to ultimately recommend the appropriate solution to the city, understanding that all cities, or no two cities are alike, and all cities are unique. We're able to ultimately recommend the appropriate solution to the city, understanding that all cities, or no two cities are alike, and all cities are unique. Give you a little perspective on this discovery process. Back to the infrastructure. With any of our customers today, what we go in and ask are really these key questions. And the goal, again, is to understand what the city has for objectives and goals, both short-term and long-term, but then also what infrastructure do they have today and what are they planning for in the future? Because all of those decisions or inputs are important for us to ultimately recommend the appropriate solution. If they want a solution to work today, we may recommend a different solution than we would if they were targeting having a solution working 2 years from now. Okay, so all key questions that have to be worked through. Another important question to understand, and obviously this is top of mind in all of the smart city context, what connectivity is available to vehicles in intersections? And I'm going to go through an example of this in a second, but connectivity is key. If there's connectivity on your vehicles to something, ideally a cell modem, that is an important piece of technology that we can use. The same holds true on the intersection side. If there's a network connection, whether it be a fiber connection, a cell connection between the traffic cabinet and the traffic management center, that again is a key point of connectivity that we can leverage, and that would avoid us having to deploy some other type of connectivity that may be redundant to what they already have. And then the last piece again, who are the key stakeholders? So this could be private partners that the city may have. This could be departments within the city, whether it be transit, EMS, fire, public works, or the traffic department and IT group. Who are these key stakeholders? Are they accessible? And then ultimately, can we get them all at the table to have a discussion around how we leverage what's in place already today? Okay, so that's a little bit about our discovery process. Now we're going to switch gears into the solutions and the levers and tools that GTT has to be able to effectively deploy a solution in the smart city. So some background context on how we view the market. So anybody that's involved in technology, who's been a part of a technology manufacturer, will likely be versed in this technology adoption curve. This really applies to any technology, whether it be social media, whether it be mobile phones or smartphones, or transportation equipment. In any technology, there are groups of people that adopt at different rates. So in this case, as an example, the innovators are the folks that are willing to accept some level of dysfunction or bugs with the product because they want to have the latest and greatest features. The early adopters want the latest and greatest features, but they don't want as many bugs. So they wait a bit for that technology to be a bit more proven before they're willing to adopt it. And then you start to move into the mass market. Those folks, again, need the technology to be a bit more proven, and ultimately that carries over to the laggards. These are the folks that are late to the game in adoption. Maybe they want to make sure before they invest the time and money in the technology that it is truly proven before they'll adopt. And so we've essentially taken this adoption curve and we've applied it to connected vehicle technology. And so this is how we view the market. One caveat to this: there's no right or wrong for where a city falls along this curve. Really, our perspective, GTT's perspective, is let's go into the city, understand where they are today, understand where they want to get to, and help them to build a path to do that. And so as you think about connected vehicle technology, broken apart to these groups, we split it in this way. So there's the laggards. These are the folks that have no V2X communication. Instead, they're really dependent on the driver and fixed signal timing to move the vehicles through the city. From there, you move to what we'd call the late majority. These are your legacy or point-to-point folks. We would put our IR customers in this bucket, so they have some level of connectivity. It's very simple and very basic. From there, you move into the early majority. So in this scenario, the technology is using remote management capability. From there, you get into early adopters. These folks have started to integrate software into the solution. They're leveraging the infrastructure they already have. And then lastly, you move into the innovators, where they have a fully integrated solution that spans multiple jurisdictions and departments, and also brings in a variety of devices and sensors and systems to ultimately provide a more cohesive and innovative approach. And this is really where the smart city falls, is in this innovator space. Our goal, again, is not to dictate where a city has to fall. It's understand where they are. So perhaps they're in a late majority and they want to get to maybe late early adopter, early innovator, or maybe they only want to go from late majority to early majority. To us, it doesn't matter. We have a variety of products that are just late early adopter, early innovator, or maybe they only want to go from late majority to early majority. To us, it doesn't matter. We have a variety of products at our disposal that we can come in to a city and basically align that to their goals. Okay, so a quick overview on the components from GTT's perspective on what we use for connected vehicle technologies and solutions. I'm going to build this up over time. So I'm going to start at kind of the bottom level. This is where, again, jump back to this slide, kind of the late majority phase for connected vehicle adoption. So what we offer is our Opticom IR solution. In that scenario, or in that solution, we have a device that goes on the vehicle. It's an IR emitter. And then we have a device that goes at the intersection, an IR detector, that ultimately connects to the 764 phase selector, which is essentially the brain at the intersection that's receiving and communicating with all the vehicles and determining the appropriate time to request preemption. It's that unit then that interfaces to the traffic controller to request that preemption or priority. So this Opticom IR technology is very simple, very basic. It was launched in the late 60s, but is still widely used today. But if you start to think about the smart city and the need for integrated solution, that's where the IR system starts to break down a bit, because the capabilities and the data that you have about the system, the vehicles, where they are, is limited. That's where our Opticom GPS comes in. So with Opticom GPS, you have, again, a device at the vehicle. You have a device at the intersection that is communicating to the vehicle, and then ultimately that's passing information to our 764 phase selector. The phase selector then talks to the traffic controller. In the Opticom GPS world, one of the unique advantages and one of the recent adds that we've had to this product line is the ability to communicate over NTCIP to the traffic controller. So for cities that are interested in adaptive or dynamic signal timing, they need advanced detection of the vehicle approaching the intersection. That could be 20, 30, 40, 50, 80 seconds in advance. So you can't get that with an IR-based system. But with a GPS-based system, the vehicle knows where it is relative to the intersection in the city, and it can report its estimated time of arrival to that intersection. Okay, so again, Opticom GPS does TSP and EVP, those two applications, but it does it much smarter. One of the other adds that we've had to this product line over the last year or so is we've made them things. If you've heard of the phrase Internet of Things, we've made them things, and there are specific technologies that we've incorporated into our Opticom GPS vehicle unit as well as our phase selector. And by doing that, we're able to connect these devices to central applications. And in this case, what I'm showing is our Opticom Smart City platform. But by connecting these devices, now in a central location, you can do more advanced applications, performance analytics, and ultimately optimize and manage your system in a much more effective and efficient way. And so we've added that capability. But what you also notice is we've added the capability for this vehicle to communicate to the intersection over cellular communication. So if you have a reliable cellular network in your city, we can potentially leverage that as a path to connect a vehicle to the intersection. And in doing that, you can avoid some of this radio infrastructure or connected vehicle infrastructure. Okay, I'm going to follow this up. The next build is a software-based, more of an integrated type approach. I have a case study here that I'm going to reference relative to New York City. This is a solution that we've deployed with them. In the case of New York City, or in any city, if you have a connection between your traffic management center and your traffic controller, whether it be a cellular connection, a fiber connection, if you have some level of network connectivity, that's a connection that we can also leverage to connect to that intersection. Necessary logic to determine the appropriate time to request preemption or priority. That will relay information to our central software. That central software can be hosted on-premise within the traffic management center or within your city's internal IT environment, or it can be hosted in an external cloud. But the vehicle software communicates to that central software, and then ultimately that will interface to the traffic management center software, ideally or typically an ATMS system, and then from there that will pass the necessary information down to the traffic controller. So you'll notice how the deployment becomes much simpler in a software world. The complexity is really in these interfaces and getting the partners to work together to effectively make the systems talk to one another. But from a hardware perspective, the hardware is essentially leveraging what it already exists. And so it's a piece of software that exists. And so it's a piece of software on the vehicle, a piece of software in the central system, and then from there it's interfaces outside of that, interfacing to a vehicle computer and interfacing to an ATMS. The last build There's a lot of funding being invested in DSRC and a lot of testing being done, driven by the US DOT and others. I want to show where DSRC plays in all of this. So in the DSRC world, what you have is an onboard unit that's deployed on the vehicle, and then similarly to our Opticom GPS, you have a radio, DSRC radio unit, as well as an RSU, and depending on the manufacturer, these could be the same unit. And then ultimately that is communicating to the traffic controller. Okay, so what's unique about DSRC relative to Opticom GPS, DSRC as it stands is evaluating potentially up to 60 applications, where cities can pick 10 to 15 that they'd like to run across this infrastructure at a given time. And again, because bandwidth limitations, cities are going to have to pick the 10 to 15 that they think are most fitting to this infrastructure. But nonetheless, for GTT, in this environment, GTT has software applications that can interface to the DSRC infrastructure for things like TSP or other popular applications or functions that are being discussed, just the basic safety message, as well as SPAT data, passing that SPAT data from the intersection to vehicles. So for GTT, the DSRC world is really another channel or an avenue for us to connect our vehicles or vehicles to intersections and infrastructure. Okay, so that's the flexibility that GTT has in our solutions today, and hopefully this gives you some perspective on how we can mix and match and use these technologies to ultimately propose a solution for a city. Now what I want to do is take you through a couple of examples of how this could play out, a couple scenarios. The first scenario that I'm going to walk you through is one where we'd look to migrate a city from more of a point-to-point connected vehicle technology to a more integrated emergency vehicle preemption approach. And so in this scenario, I pull out some kind of hypothetical goals, but these are very common to what we hear from our customers today. So if we were to work with a city, maybe they had some goals to reduce maintenance costs, they wanted to optimize traffic flow, they wanted to be able to analyze the performance of their system in more real time and centrally, and then ultimately they also wanted to incorporate other modes into this kind of EVP, or emergency vehicle preemption and priority system. And so from there, understanding those goals, we'd say, all right, let's put together a migration plan for the city to go from where they are today to where they want to be in the future. And so the first step to that, we would go in and evaluate the existing infrastructure that they have. So in this scenario, what they'd have is Opticom point-to-point technology. So in this case, infrared technology. So as I mentioned, they'd have an infrared emitter on the vehicle, a detector at the intersection, and then a phase selector at the intersection that ultimately communicates to the traffic controller. But through this discovery process, we also learned that they have connectivity to the traffic management center over a fiber connection. That's an interesting insight for us to say, okay, if you already have that connection point, let's evaluate an integrated or software-based approach, because that again, that's much easier to deploy, much easier to manage, because you eliminate some of the hardware components. So to start to migrate to that path, if all those other questions were answered, we could get the key stakeholders to the table. We could get, the private kind of manufacturer vendors at the table, and ultimately come up with a goal of deploying an integrated approach. The next step for us would be starting to build to it. So the second step would be install new vehicle connectivity at the vehicle. So in this case, the most common scenario would be installing a cell modem on the vehicle. Ironically enough, most vehicles today have some level of connectivity, a modem on their vehicles. The question then is, can we access it? Can we use it as a technology provider? But assume in this scenario they don't have a modem. So if they don't have a vehicle computer, we can install a device to get the necessary information on the vehicle. But regardless, if they have a compatible vehicle computer, we want to leverage that. If they have GPS, we want to leverage that. So install that software on the vehicle, And then the traffic management center, we would install our Opticom Central software and then interface that to the ATMS. So in this scenario now, you have your software talking over cell to the central software at the traffic management center, and then from there it'll pass the request information to the ATMS, which ultimately routes that to the appropriate intersection. And then in this scenario, we could maintain the IR communication as a backup or secondary communication mode in the event that cellular communication is lost, or this connection between the ATMS and the traffic controller does not exist. They can use infrared as a primary mode of communication at those intersections. And common scenario where cities don't have this connectivity across the entire city, but they may have infrared at certain intersections. So we want to continue to maintain their ability to leverage that existing infrastructure as opposed to having to rip and replace. Okay, and then the last step that I mentioned would be to migrate to a multimodal world. So now that they have this central solution built, where they have the infrastructure, central software, interface to the ATMS, now it's simply going to each of the vehicle modes, the types that they want to add to the system, deploying Opticom software on the vehicle computer that they have. And again, if they don't have a vehicle computer that's compatible, we can install a device that will gather the necessary information, leverage that cell modem, and then from there communicate back to the central software and then out to the intersection. And the central software has the ability to manage and prioritize the requests across all of these different modes. So we ultimately enable the traffic engineering department in the city to make a decision around how the priority should be managed and how the traffic signals will be impacted by the request from each of these other vehicle types. Because obviously, as you guys know, a preemption request is not the same as a signal priority request. And then as we move into the freight signal priority world, that'll be another lever for traffic engineering to use. So from our perspective, we want to provide the capabilities to receive requests and information from all of these modes, and then offer the traffic engineering department the configurability to determine how these modes should be processed. So in this scenario that I walked you through, we essentially took a city from a point where they were, if you look at all of the modes, potentially they were at the early, kind of late majority phase, and we moved them to kind of the early adopter innovator phase, or stage. Okay, so now I want to take you through a real scenario, a case study that we put together with the New York City, and specifically New York City MTA. So, quick overview on New York City. So they have 5.9 million subway and 2.3 million bus trips daily, 5,700 buses operating on 2,800 miles of routes. The public transit system is operated by the MTA, and then you also have 13,000 traffic signals operated and maintained by the New York City DOT. Another interesting point about this project, when they approached GTT, right around 2010, 2011, New York City has the highest passenger loads in the US, but they also had the slowest moving buses, and that was declining. And that's what led them to evaluating transit signal priority and ultimately pulling GTT or reaching out to GTT to help work with them to come up with a solution. So some of the challenges that they faced: very dense population, heavy pedestrian traffic, double parked vehicles, having to maintain traffic coordination because 2, 3, 4 seconds stole from side streets in certain parts of the downtown area could have a significant impact on the flow of traffic in the downtown area. Urban canyon effect, which inhibited obviously the GPS, different communication standards and security, and then they also had multiple agencies involved. So if you think about New York City and the politics, in this particular project, we kept it largely contained to the New York City MTA and the DOT, but then there are a number of vendors externally that we had to pull in as well, and key stakeholders that we had to work with along the way to keep them engaged in the project. Okay, so switching now to how we tackle the project. It's reserved solely for New York City to use for communication for critical city operations, which includes connection or communication between their traffic management center and their intersections. But it also spans emergency services. So the city had this nice wind network where they connected their traffic management center to those 13,000 intersections. They also had an ATMS by TransCore, and then they were working with an outside firm called GPI, consulting firm, for their traffic engineering. So the New York City MTA brought GTT in and said, GTT, we have plans to, deploy a computer down the road, GPS, cell. So we have plans for vehicle infrastructure. We also have this connectivity already in place to our intersections. It's not feasible for us to put additional hardware on 6,000 vehicles. It's not feasible for us to put additional hardware at 13,000 intersections. What can we do leveraging what we have today? And that ultimately is where GTT developed our first integrated software-based solution. And because this was new, the first step to the new project, understanding high-profile New York City, have to make sure it works, we had to do a pilot. And so the solution was GTT software at the vehicle, leveraging onboard computer, leveraging GPS, leveraging cell, and then our GTT Central software that actually resided in the New York City MTA server environment, but then we had to interface that to the ATMS that existed in the New York City DOT's Traffic Management Center. Okay, so we went into a pilot, and they selected the M15 route, Wall Street Financial District, if any of you are familiar with it, and they selected the M15 route, Wall Street Financial District, if any of you are familiar with that, Lower Manhattan, second highest passenger loads in the city, lots of pedestrians and bikes, unloading trucks, very heavily congested. Also, side street coordination was critical, and then urban canyon effects. So success was highly unlikely, but that's why they picked this corridor, because they said if we could make it work here, we can make it work anywhere. Long story short, working with GPI, they did much of the traffic engineering work to model the traffic movements on this particular corridor, and then ultimately implement and help configure the TSP solution. And the results were very good. A couple points here. So M15 lowered bus travel time up to 18%. The New York City Transit, or MTA, actually put out this report called Green Means Go. You can find that online. I have a link here. But one of the quotes from that report: since 2012, New York City DOT has worked with the MTA to implement TSP on 5 corridors with excellent results. They talk about each of these corridors in that study, and since that time, they've made the decision to expand TSP across the entire fleet, 6,000 vehicles and 13,000 intersections. So we've been working with them over the past couple of years to expand this out. So in the case of New York City, we took them from a point where on their buses, they were really early adopters when it came to network connectivity, with that nice wind network to their intersections. But from a connected vehicle perspective, specifically on their transit services, they were a laggard. They had no connected vehicle technology. So we took them from a point of being a laggard with connected vehicle to really an early adopter with this integrated approach. Okay, so that hopefully gives you some perspective on the flexibility of the solutions. It also, I'm guessing, has brought a whole host of other questions around technology and how to actually sort through all of this. So one of the other services that GTT recognized and has since rolled out is a service called Priority Control as a service. So the goal is to take all of this complexity around integration and solutions and management out of the customer's responsibilities and set up a scenario where there's no equipment to own for customers and nothing to maintain. Instead, for a monthly fee per vehicle per intersection, GTT will actually take over all of the hardware, software, and management services of the solution. So that's everything from working with your city to understand what you have for infrastructure, determining the appropriate solution with the key stakeholders, installing the solution, and then proving the solution, optimizing it, and doing post-reporting to ensure that you're getting the most out of that solution. If the solution breaks, we'll come out and fix it. And we're monitoring the solution so that we know if it breaks to go and take care of it. So the idea with priority control system is working or not. Essentially, just show up and get the green light. Okay, so I do want to just mention that as a service in the event that the technology piece or maybe your staff is a little bit limited to be able to manage all the technology. We do have solutions and services that we can provide to help you get through that. Okay, some scenarios that I want to kind of take you through. Recent deployments where GTT is working with customers in these exact scenarios. I mentioned New York City MTA, and that example, we've deployed transit signal priority in an integrated software-based approach. We're using cellular and wireless connected vehicle communication, and then it's high volume. So we can scale it up to 5,700 buses and 13,000 intersections. Montreal, we've been working with them for the past couple of years. Number of areas, multimodal planning that spans not only connected vehicle technology migration. So across the region, they have a mix of infrared and centralized capabilities as well as Opticom GPS. So we're working with them to put together a migration plan that minimizes downtime to their existing services. IoT and data management is also a core to the city's strategic initiatives. So we're working with them to put together plans to manage that. And then we're deploying an integrated software-based TSP and EVP approach, leveraging cellular communication. In San Francisco, we've actually been helping them for the last couple of years on a technology migration project from technology that we deployed a couple of years ago to get them to our latest technology, specifically our Opticom connected vehicle platform. We've also helped them on a number of aspects beyond transit signal priority. So not only are we helping them move their buses more quickly, but also more consistently with our advanced schedule management, where that's all about keeping buses on time. And then we've also been contracted to provide their turnkey services for performance management of their transit signal priority solution. So that's regular reporting on how the system is performing, but then also managing the maintenance of the system to ensure that they're getting the most out of it, because they don't have resources dedicated specifically to transit signal priority. So we're taking that burden off of them. The region of York in Ontario, they have a multimodal management project where we've blended transit, the fire department, and public works, specifically snow plows, in a Preemption priority solution. They actually won an ITS award for this solution. There's also blended technologies, so it's a blend of Opticom IR and Opticom GPS across those modes. And then the last one, Hayward, California, Fire Department. We have actually worked with them to deploy our priority control as a service, where again it's emergency vehicle preemption, fully managed by GTT. So everything from the installation, configuration, ongoing maintenance, and performance management. We're doing all of that for them. So they essentially show up and get the green light. And we've since rolled this out in Hutto, Texas, and we're in the process of finalizing contracts with a couple others as well. Okay, so to bring this all together, there are a couple of key philosophies that GTT has incorporated into our solutions. The first is this ability to support our customers in migrating over time. So if you think about what that means, regional planning, regions will evolve. You'll have situations of mutual aid where departments need to span multiple jurisdictions, and also a blend of technologies, Opticom IR, Opticom GPS, Opticom GPS, Perhaps they're going to have DSRC or centralized cellular-based solutions. We work with companies or customers to sort through this. Also, multimodal support. Again, you have public safety, public transit, public works, and the variety of vehicles and technologies that may exist across all of those. We come in, work with cities to put together the right plan based on that technology. And then the other philosophy is really minimizing redundancy. I'm sure you all have seen vehicles that look like this, where they have multiple computers, multiple GPS, multiple cell modems, and ultimately multiple antennas on the roof of the vehicle. Instead of deploying more hardware, we take the approach of understanding what the city has in place today and then recommending a solution that leverages as much as possible that infrastructure that they have in place. Again, make the system easier to maintain, easier to manage, and then recommending a solution that leverages as much as possible that infrastructure that they have in place. Again, make the system easier to maintain, easier to manage, and hopefully cheaper for the customer in the end. All right, so to recap, smart cities or smarter cities are essential to create more sustainable and livable communities. GTT has a breadth of intelligent transportation solutions to guide you on your smart city journey. And GTT has the experience and knowledge to change the way your city moves today and in the future. And I do want to thank you again for taking the time out of your busy day to listen to this presentation. If you do have questions, I'm more than happy to entertain those. Feel free to reach out. We have a number